Hi, everyone. Today we're on Unit 9, Lesson 2. We're going to be verifying trig identities. So as we stated last time, an identity is simply an equation that states that two trigonometric expressions are equal to each other for all values of theta. Let's just stop for a moment. Let's consider the equation. Secant theta minus cosine theta equals sine theta times tangent theta. Let's show that both sides of the equation will be equal to the same value if theta equals pi over 6. And now, by now, you guys know whenever we see radian measure, we usually convert it. So we're talking about a 30-degree angle. So we want to show that the secant of 30 degrees minus the cosine of 30, I don't need parentheses, equals sine 30 times the tangent of 30. So we want to set up the function values for all of these trig functions here. We're going to take our 30, 60, 90-degree triangle. And put our ratios in. The secant of 30. Well, the secant of 30, if you remember, is 1 over cosine. Now we could write it like that, or we could write the cosine, do the cosine and flip it. So the cosine would be cosine of 30 adjacent over hypotenuse. So the secant is 2 over rad 3. I'm just going to leave it like that for right now, and I'll do my math later. And my cosine of 30 is rad 3 over 2. Right, I'm just setting up the function values. Sine of 30, opposite over hypotenuse, times tangent of 30, which is opposite over adjacent. I might convert this one, rad 3 over 3. It might be a little bit easier. Who knows? So I have on the left side now, I've got to add those two fractions together. We may actually rationalize this. 2 rad 3 over 3 minus rad 3 over 2. So I have to multiply this fraction by 2 over 2 and this one by 3 over 3. So I have 4 rad 3 minus 3 rad 3 all over 6. And I want to know if that equals rad 3 over 6. Well, if I do the math for 4 rad 3 minus 3 rad 3, I get rad 3 over 6, and that is equal to rad 3 over 6. So our statement is true. Now, through the above work, though the above work shows that both sides of the equation have the same value for one particular value of theta, this is not enough to show that these two expressions are equivalent for all values of theta. We must show analytically that these two expressions are equivalent. Okay, so how do we do this? To do this, our goal is to rewrite both sides using basic trig identities and show that one side can be, each expression can be simplified to the same expression. This could mean that the left side can be rewritten as the right side, or the right side can be rewritten as the left side, or both sides can be rewritten to form separate equivalent expressions. Now, what we do here is going to really be based on what the original expression is. And I'll try to explain that as we move through examples. Okay. The big thing here is don't cross over your sides. We're going to rewrite each side until we get things that are equal. Okay, that's the big thing we have to worry about. So I'm going to rewrite my left side. When I see the words analytically show the equations are represent identity statements, we're verifying that the left side equals the right side. Now, since both of these sides are complicated, meaning I don't have one in terms of one single trig expression, I'm going to rewrite. And I usually try to start with rewriting in terms of sine and cosine. That usually gets me what I need. And then I'm going to use the algebra we went over yesterday to simplify. 1 over cosine minus cosine, and that's going to equal sine times sine over cosine. Over on the left side, I've got to add these two together, these two expressions. 1 minus cosine squared over cosine equals sine squared over cosine. And hopefully you guys now see and recognize when you see the Pythagorean identity. So 1 minus cosine squared is going to be sine squared over cosine equal to sine squared over cosine. And just to be formal, we should put our angle back in, right? We just kind of took it out to make it quicker. And we show that these two actually match. Now, there are other ways to kind of represent this answer, because I know sine squared is really sine times sine over cosine. So I could have sine theta times tangent theta equals, and again, sine theta times tangent theta. And that matches as well. Okay. In that case, we could have actually left this alone until we got it to match. That's why these problems are weird. And some of us may do things a little bit differently than others. And I'm going to do my best on on an exam or whatever, an assessment, to try to guide you to the form that I want you to leave it in. But either one of these answers would be acceptable. Just like we did yesterday, we're going to kind of work through, and whatever we don't do, I'm going to put a little highlighted next to it, and that's a homework. Now here, I guess we'll go down the left side. Actually, I'm going to do the right side. So this will be a homework. And I'm going to do the right side problem because we're going to use it down below in a minute. Cosecant theta minus sine theta equals cosine times cotan. I'll just rewrite each side. 1 over sine minus sine equals cosine times cosine over sine. And again, I might have done more work than I needed to, but I kind of like to see it in sines and cosines. So to get this side as one fraction or one single quotient, I'm going to multiply by sine over sine, add across the numerator. And again, my Pythagorean identity, cosine squared theta over sine theta equals cosine squared theta over sine theta. And I'm happy with that because I got them both to match. So I'm okay to leave it in that form. Now we'll go back and do one on the left. Sine theta over cosecant. All right, so I'm going to start by rewriting in terms of sines and cosines. This one looks a little bit complicated. So sine 1 over sine plus cosine times 1 over cosine. I'm going to leave the other side alone for right now. I'm just going to work on cleaning up the left. Common denominator, I want to simplify this complex fraction. So I have sine squared plus cosine squared equals. Now, if you can manipulate your Pythagorean theorem to get, let's just see if we can, cosine squared plus sine squared, equals 1. Secant squared theta minus, I can rewrite my secant squared, I can rewrite my tan squared if I wanted to. Or I'm probably just going to take and focus on rewriting each one of these and simplifying from there, because I think using my identities is just going to be a little too much for me. 1 minus cosine squared minus sine squared over cosine squared. And if I combine these two fractions together, I have 1 over cosine squared minus sine squared over cosine squared. I feel like I messed up. Oh, so this is going to be 1 minus sine squared over cosine squared, which is just cosine squared over cosine squared, which is 1. And I know on the left side, sine squared plus cosine squared equals 1. So there's your identity. You made them equal to each other for all values of x. Homework. Now let's go back down. Let's do the last problem here. Okay, and we'll talk about why we can't use. Okay, this example is going to show us that why we can't just plug in an angle and say it's true for every value. So in your work above, you verified that cosecant theta minus sine theta. So we verified cosecant theta minus sine theta equals cosine theta times cotangent theta. We showed that it was an identity, and let's go back to that for just one moment. We showed that this guy here was an identity. Explain why theta equals pi would not be an appropriate value to try to show numerically that this equation. So we'll talk about why we can't just plug in an angle and use that as our verification. So if we're going to plug in pi, I would have cosecant pi minus sine pi equals cosine pi cotangent pi. And since I have cosecants and cotangents, I'm probably going to work off my unit circle. Pi is this guy here. And I know my x value is my cosine and my y value is my sine. Cosecant pi is really 1 over the sine of pi. So 1 over the sine of pi is going to be 1 over 0. I get undefined. Therefore, I can't use this. As numerical proof. It doesn't work. And if we do the cotan, you'll see you get that as well, because cotan is cosine over sine, which is negative 1 over 0, and again here, undefined. So this is why we can't just say, but it works for this value, because it may not work for others. It's equivalent for all values, because we're getting undefined, but undefined is not numerical proof. Okay. So again, this is why we go back to analytically show. We want to show for any given value. Okay. I think I may just, how many questions would you have for homework then? 1, 2, 3. We'll do 2 more problems on this page and then we'll call it a day. Let's start with the problem on the left here. Show that the equation, so secant theta, I want to look at the math. I have to FOIL that side. So I'm going to have first times first, secant theta times cosecant theta. Outside plus secant theta. Ugh, I don't want to do it that way. Let's rewrite this in terms of sines and cosines so it can be quicker. Secant theta is 1 over cos. Cosecant theta is 1 over sine. Cotan theta is cosine over sine. And that's going to equal tan theta. We're going to leave that side alone. That's one expression already. We might try to just get our left side to match it. First times first. 1 over cosine sine. Outside. Negative cosine over cosine sine. Inside. 1 over sine. Last times last. Again, we're going to have a minus. And that's going to be cosine over sine. And remember, we're trying to get this to equal tan theta. I'm just checking that I did my work right because I feel like something got messed up. 1 over cosine sine outside. Ah, I didn't simplify. So that's just a -1. I have -1 over sine plus 1 over sine. So these guys are going to go away. I'm left with 1 over cosine sine minus cosine over sine. And that's equal to tangent. Again, I didn't rewrite that. I'm just going to leave it and see what happens. If I need to rewrite it to make it match, I will. Common denominator. So I have 1 minus cosine squared over cosine sine is the same as sine cosine. So I'm just going to, and that's equal to tan. 1 minus cosine is sine squared over cosine sine. One of those is going to cancel. And I get that sine over cosine, or tan theta, equals tan theta. So I did this one a tiny little bit differently just to kind of show you that you could leave one side alone if you want to and get the other side to match up. Okay, so you may have to do this sometimes. That's why I'm showing you different methods to use. We're going to go with the homework. And I guess I'll do this last problem with you guys, and then we will shut it down for the day. So I have cosine theta over 1 minus sine theta minus cosine theta over 1 plus sine theta equals 2 tan theta. Again, I'm going to leave that right side alone because it's one trig expression, and I'm going to see if we can get them to match. On the left side, I have 2 fractions. I can't do anything about the individual fractions, so I'm going to have to add them together. So I'm going to have to multiply 1 plus sine, 1 plus sine, right? 1 minus sine, 1 minus sine. Now remember, when we do this, our denominator is going to become 1 plus sine, 1 minus sine. And I'm not going to worry about that right now. I'm going to see if I need it in the future. In the numerator, cosine plus cosine times sine. Now here, I'm going to subtract what I get. So I have cosine plus sine cosine. And I'm going to subtract cosine minus cosine sine. Remember, I'm subtracting that entire quotient. So subtracting the entire set of parentheses. Minus cosine plus cosine sine. My cosines cancel. I'm going to have 2. I'm going to write this out. And now in the bottom, when I FOIL this, I get 1. My outside and my inside cancels out. 1 minus sine squared, which is really cosine squared theta. Cancel, cancel. 2 times sine of theta over cosine theta is 2 tan theta equals 2 tan theta. There's your identity. If at this spot here, let's just work it the other way. Let's say you took this side here, 2 sine theta over cosine theta, and you said, well, I want to rewrite this side. You could get it to match that way. Either way is appropriate. Okay, so you're going to do the highlighted questions that are left on the page for your practice tonight, and I will see you again soon.